Hi, and welcome back to the channel. This week I've got a really cool problem for you, and that's trying to work out the shaded green area in the diagram that you can see. Now, we have got an equilateral triangle. We have got three semicircles that touch each corner of the triangle and also touch with the other side of the semicircle, the center of gravity of that triangle G. Now, it's an equilateral triangle, and as you can see, we've got a length from the apex of that triangle down to meet the or be a tangent to the semicircle at h, so b to h of length 6 centimeters. Can you work out the shaded area and solve this problem? If you want to have a go at the problem yourself, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I'm going to do is get rid of all the letters to tidy it up a little bit. And I'm going to draw on a radius, okay? Radius, going to call it R for radius. And that is going to meet the tangent at a right angle, because one of the circle theorems is that a radius meets a tangent at 90 degrees. So let's put that on. Now, from there, what I'm going to do is I'm going to take this line from here to our center of gravity G, and I'm going to extend it. Now, I know that this angle up here will be 90 degrees. And the reason that is because if we look at that top semicircle, we've got a triangle then made in that semicircle, and an angle that a triangle makes in a semicircle is 90 degrees. Okay, now from there, I can start labeling some of my radii. So I've got my two radiuses there of my semicircle. Now, these semicircles have to be identical. They have to be exactly the same semicircle, because they are going the same distance. They've got the same radiuses. They're going from the center of gravity to each apex or each corner of your triangle. So what I then know from this, I've got my radius, is that the length from G here to my right angle is going to be R, and I've given you a bit of a spoiler for the next bit, but the reason this is R is because the distance from each corner, if you do a straight line to the center of gravity, is 2/3 of the way, 2/3 of the distance from the corner to the opposite side of that triangle. So because I've got two radii there as part of that distance from my corner to G, then I know that the other or the rest of that line must be half of that. So instead of being 2R, would be half of that was 1R. Okay, it's 1/3 of the whole distance. Okay, so 2/3 there, 1/3 here. Now, the next bit is, as you probably saw, these angles, they're going to bisect, because this is a line of symmetry, the 60 degrees into 230 degrees, okay? Now, all of these lines, if we were to extend them, would be lines of symmetry, okay? And that's important as well. Right, now from there, what I'm going to do is I've got this right-angled triangle here that I've highlighted in purple. I'm going to look at that triangle, and I'm going to work out this side length up here. So that side length. Now, the way I'm going to do that, because I've got this 30 degrees down here, is by using trigonometry, right-angle trigonometry. And I'm working on the opposite. I've got the adjacent in terms of R. So I'm going to use tan. Tan 30 is going to be the opposite over the adjacent. The adjacent is 3R. Now, tan 30 is √3/3. I'm then going to times both sides of that by 3R, and I'm going to get 3R √3/3, which simplifies to R √3 being the opposite. So let's put that on the diagram. Okay, now from there, I am going to introduce another line, this line here. Now that is going to give me two triangles, two right-angled triangles. So there's one in purple. Here's another one in green. And I'm going to get rid of all the rest of the stuff here and just keep the important bit. So here are two right-angled triangles, and we've got lengths √6, we've got lengths of R, we've got lengths of R √3 and 2R. Now, using Pythagoras with both of these triangles, I should get the same answer for that red line, that hypotenuse for both of them. So let's do that. Root 6 squared plus r squared is the hypotenuse squared, which is r root 3 squared plus 2r squared. Now we simplify that and get rid of that hypotenuse in the middle because we don't need it because they're both equal to each other. We're going to get 6 plus r squared is 3r squared plus 4r squared. So 6 plus r squared is 7r squared. Take away the r squared from both sides. We get 6 is 6r squared. Divide by 6. We get 1 is r squared. And so r must be plus or minus 1. Now, obviously, because it's a length, it's a radius, it can't be negative 1. So the only solution is the radius is positive 1. Okay, let's go back to our diagram. And let's replace all the r's with 1 here. There we go. Now, the next thing I'm going to do is I'm going to get rid of all of that stuff, and I am going to introduce this new radius here. Because we've got the radius of all our semicircles now. So what we need to do now, what you could do now, at least, this is what I was thinking when I was doing my solution initially, is introducing this new radius and just working out the sector, working out the triangle and subtracting to get the segment, and then timing by 3 because those those semicircles are identical. They're congruent. They are exactly the same. But I know that angle is 30 degrees because I've got an isosceles triangle here. Okay, same lengths. This is 120 degrees. And then I thought something actually quite cool, I think, because it's 120 degrees, which is a third of 360 degrees. And I looked at these semicircles, these congruent semicircles, and I thought, well, actually, what about if I got rid of all the stuff in the middle? And what about if I did this? Made that triangle smaller. Those segments of the semicircles could be put together into one circle. And now all we need to do is work out the area of that circle and take away the triangle. Now I'm going to put on the root 3's there as well, and we've got 60 degrees in the corner because it's an equilateral triangle. So let's make that a bit bigger, a bit easier to see. Like I say, all I've got to do now is work out the area of the circle, which is pi times 1 squared. That's pretty easy. That's just pi. And then I've got to do the area of the triangle, which is a half AB sine C. So half root 3 sine 60, which is 3 root 3 over 4. And then you just subtract the 2. So the shaded area is pi minus 3 root 3 over 4 units squared, which is about 1.8 and some other decimal places after that. If you manage to solve this problem, well done, first of all. And if you had the same solution as me, let me know down in the comments. If you had a different solution, please also share that down in the comments below, because it's really useful for me to see and really helpful for everybody else to see the different solutions that you can use. And if they got stuck, they could look at your solution and follow that on from wherever they managed to get up to. Thank you so much for watching. As always, if you enjoyed this video, please drop a like on the video. And if you're not subscribed, please consider subscribing to the channel. There will be other videos up here. Please click on one of these, this one. Hopefully it's something you want to watch. But anyway, thank you so much. I'll see you next Monday at 5 PM for another problem solving video. Until then, bye-bye.